Science, Grade 10, Unit 9, Resultant Force, Unit 12, Equilibrium of Forces. These are the subtopics. The resultant of several forces 9.1, 9.2 resultant of two collinear forces, 9.3 resultant of two parallel forces, 9.4 resultant of two inclined forces. That's what we are going to discuss. Now, what is a force? Force, I think you all have learned, force is a push or pull of an object is considered a force. Push and pull come from the objects interacting with one another. Terms like stretch, lift, squeeze can also be used to denote force. Stretch, squeeze, lift can also be used to denote force. In physics, force is defined as the push or pull on an object with mass that causes it to change its velocity. What are the features of a force? Force is an external agent capable of changing the state of rest or motion of a particular body. What are the features? It has a magnitude and a direction. Force is a vector quantity. I think you all know about that. Force is a vector quantity as it has a magnitude and a direction. The direction towards which the force is applied is known as the direction of the force. And the application of force is the point where force is applied. Now look at this diagram. An object is shown here. 100 Newton is applied on this object. The force is 100 Newton applied on this object, and the direction is shown by this arrow, and the point of application where the force is, the point to which the force is applied is called the point of application. How do you measure force? In your science lab, we use a spring balance to measure force. We use a spring balance to measure force. What is the unit of force? The SI unit of force is Newton. The SI unit of force is Newton. We denote it using capital N. What are the effects of force? In physics, motion is defined as the change in position with respect to time. In simpler words, motion refers to the movement of a body. Typically, motion can either be described as change in speed, change in direction. The force has different effects, and here are some of them. Force can make a body which is at rest to move. It can stop a moving body or slow it down. It can accelerate the speed of a moving body. It can also change the direction of a moving body along with its shape and size. Shall we summarize it again? The things that push or pull a force could do: a stationary object can be moved, a moving object can be made stationary, the direction of a moving object can be changed, the direction can be changed, the speed of a moving object can be reduced, the speed of a moving object can be increased or accelerated. Now, what is a resultant force? The single force acting in place of many forces. The single force that gives the same result as many forces is known as the resultant or net force. Now, I have given you the definition here. A number of forces acting on a body may be replaced by a single force. That single force is called the resultant, which has the same effect on the body as the original forces, all acting together. I am going to show you some more examples. Right, now look at this picture. You can see an object and two forces are applied on this object. One is 3 Newton and the other one is 2 Newton, two parallel forces. Right, what is the resultant of these two forces? Instead of these two forces, we can apply a single force. How much is it? That is the resultant or the net force. Now, if you add these two together, so if you add these two, it's 5 Newton. The resultant of these two forces is 5 Newton to the same direction. The resultant is 5 Newton to the same direction. Now, look at this picture. You can see two people are pulling a huge weight, a box, and they have applied two forces to the same direction. What is the resultant of these two? Resultant of these two is F1 and F2. You have to add these two together. The direction of the resultant force is to the right. Now they are dragging, pulling this heavy weight to the direction of right. So the resultant, how do you find the resultant of these two forces? You have to add these two, F1 and F2. Then you can find the resultant. Now look at these pictures. First picture shows tug of war. Now they have applied forces on the rope, two opposite forces. There are many people, but the force applied on the rope is, now to the right there is a single force, to the left there is another single force. Though there are many people, the forces applied on the rope only two forces. They are resultant forces. Right. So if these two are equal, the rope will not move to either right or left. Then the rope is in a balanced position. If the force to the right is high, then these people will drag or pull the rope to this right direction. If this force, left side force is high, the rope will move to the left side. If these two forces are equal, rope will not move to either left or to the right. Now look at this picture. Now the three people are applying three parallel forces. These are three parallel forces applied on the car. The resultant is shown by this black arrow. It is also towards right, the resultant. Instead of these three forces, you can apply a single force, that is the resultant force. Now look at this picture. You can see some people are pulling a net, a fishing net. Though there are many people, a single force is applied on the net, that is the resultant force. So that is to the left side. The resultant acts on the net is to the left. The resultant force, now that this is the definition. The resultant force is a single force which can replace two or more forces and produce the same effect on the body as the forces. Now look at the first picture shown here. The resultant of collinear forces. Forces in same direction. The resultant force R, the resultant is represented by capital R. It would be 200 Newton and 150 Newton to the same direction. The total is 350 Newton to the right. The resultant is 350 Newton to the right. Now forces in different direction. Now look at this picture, 150 Newton to the left and 200 Newton to the right. The resultant force would be 200 minus 150 Newton. The resultant would be 50 Newton to the right. Now look at these three examples given here. The sum of all the forces in a system. Look at the first picture shown here. Upward force is 1200 Newton. Downward force is 800 Newton. The resultant or the net force is 400 Newton up. 400 Newton up. And look at this picture diagram. This one shows 600 Newton upward force, 800 Newton downward force. The resultant would be 200 Newton downwards. The resultant is 200 Newton downward. Now look at this picture. There are two forces, upward and downward, 50 Newton, 50 Newton. These two are equal. So the resultant is only to the left, that is 20 Newton. Now look at this picture. The net force or the resultant force on an object is the sum of all forces acting on that object. Now you can see 4 Newton to the left, 10 Newton to the right. So the net force is 6 Newton to the right. It's easy for you to calculate. Now look at these two examples given here. Net force or the overall force, or we can use resultant force. Now 10 Newton to opposite direction. So the net force is 0. Second picture shows 10 Newton and 6 Newton again to the opposite directions. So the net force is 4 Newton to the right. 4 Newton to the right. Now look at this figure. You can see a trolley. There are two parallel forces applied on the trolley. One is 60 Newton, the other one is 30 Newton. So the resultant would be two parallel. Now here this picture shows two parallel forces. The resultant is 90 Newton to the right. Now second picture shows two opposite forces applied on a trolley, 10 Newton to the left, 30 Newton to the right. The resultant is 20 Newton to the right. Now look at this picture. Two people. You can see two people. They have applied two forces on a huge box shown here. F1 and F2. The resultant is F3. How do you calculate the resultant? Resultant is F3 is equal to F1 plus F2. F1 plus F2. F1 plus F2. Now you all can calculate the resultant of these figures. What is the resultant of the first figure? Two parallel forces are applied on this object. One is 3 Newton, 4 Newton. What is the resultant? Resultant of these two parallel forces is 7 Newton. And in the second example here, how many forces are applied on this object? You can see 4 forces are applied. There are two parallel forces to the left, two parallel forces to the right. What is the sum of these two forces? 7 Newton. And here 6 plus 5, 11 Newton. So the resultant of these forces is 11 minus 7 Newton equals 4 Newton to the right. Now we are going to discuss about resultant of two inclined forces. What are inclined forces? Now look at this picture, the first picture. You can see two people. They are pulling a cart on a track. Right, they have applied the forces to an angle. You can see an angle here. So these type of forces applied to an angle is called inclined forces. Now they have applied two forces on this cart. Now look at this diagram. The force 1 and force 2, they show the inclined forces. Then what would be the resultant? Two forces, force 1 and force 2, that act with their lines of action inclined to one another is shown in this figure here as well as here. Here 3 Newton and 4 Newton, the lines of action. Now these are the lines of action. They are inclined to one another. When two such forces are applied on an object like this, the object doesn't move to either this direction or to this direction. In such an instance, the direction of motion of the object lies in a direction between the two forces. The resultant force is like this. Now, if we take this picture, 3 Newton, 4 Newton, two inclined forces are shown here. The resultant would be somewhere here. The capital R shows the resultant of these two forces in between these two forces. The object will not move to 3 Newton side or 4 Newton side. The object will move to this direction. The resultant will be here. Now we are going to discuss Unit 12, Equilibrium of Forces. Equilibrium of Forces. In that unit, you can see 4 subtopics are given. 12.1, Introduction to Equilibrium of Forces. 12.2, Equilibrium of a body under two forces. 12.3, Equilibrium of a body under three coplanar forces. Coplanar means same plane, parallel forces. 12.4, Equilibrium of a body under three forces that are not parallel. Here we can use the word inclined as the previous lesson. Inclined forces. Right. A force is a vector quantity, as I explained earlier, which means that it has a magnitude and a direction associated with it. If the size and direction of the forces acting on an object are exactly balanced, then there is no net force acting on the object, and the object is said to be an equilibrium. If there is no net force or resultant force, the object is at an equilibrium. That is our lesson, equilibrium of forces. That's what we are going to discuss. Now look at the first picture. Here, first we will take equilibrium of a body under two forces. First we will take equilibrium of a body under two forces. Now look at this picture. The weight acts towards the earth. The weight acts towards the earth like this, and the earth applies a force on the body of this person, upward force. These two are equal and opposite in direction, so the person is stationary. No net force, F equals 0, no resultant force. So if these two opposite forces are equal, the body is in equilibrium. Now if they ask you to mark the arrows, you should draw the arrows like this. Sometimes they will ask you to, at the exams also, sometimes you have to indicate the arrows. So you have to draw the arrows like this. Next example, a weight is kept on a table. What are the two forces in equilibrium? Now weight acts towards the earth. This is the weight. The reaction or the perpendicular force acting from the table is shown by this arrow. These two are equal and opposite. So the object is in equilibrium. Now you have to mark the weight and the perpendicular reaction like this. Now if you take this example, there are two opposite equal forces. That means the object is in a balanced position, in equilibrium. These two opposite forces are equal and opposite in direction, equilibrium. Now this, if we take this tug of war, here also they have applied two equal opposite forces. So the rope will not move to either right, the direction right, or the left if the two forces are in equilibrium. Now look at this, the same example is shown here. The book is kept on a table, the weight of the book acts towards the earth, the reaction from the table is shown by this arrow. There are two opposite equal forces shown in this. So the book is in equilibrium position. Now a lamp is shown here. The two forces, the weight of the lamp acts towards the earth and the tension is shown by this arrow. So these two forces are equal and opposite, and the lamp is in an equilibrium position. Now look at this. A ball is hung from a thread. The weight of the ball acts towards the earth. The tension is shown by the tension in the string is shown by capital T. So these two are two opposite forces which are equal, and the ball is in an equilibrium position, balanced. Now if you keep something on your palm, now the force, the weight of the body, the object will act towards the earth. Earth's mass or the weight on the ball is shown by F, and the hand also applies a force on the object. It is shown by this F, upward force. This is the down force, up force. So these two are opposite and equal. This is also an instance where the equilibrium of forces is explained. Now we are going to discuss about equilibrium of a body under three coplanar. Coplanar means the same plane, parallel forces. Equilibrium of a body under three coplanar parallel forces. You can see a swing here. The weight acts towards the earth, one force, and the tension of the ropes are shown by F1 and F2. Here you can see three parallel forces. How many forces are shown here? Three parallel forces. Now look at this picture. Here also you can see three parallel forces. The tension of these ropes are R, and the weight of this W. Right, you can see three parallel forces shown here. You have to mark these parallel forces if they give a picture to mark the forces acting on an object. So you have to mark by using arrows like this. Equilibrium of a body under three coplanar same plane parallel forces. Some more examples. Now look at this bike. Here also you can see three parallel forces. Reaction from the earth. There are two upward forces and the weight acts towards the earth. So there are three parallel forces here also in this instance. Now look at the next picture. What is it? We'll see. Right. This picture shows a bench. You can see there are also three parallel forces. Reaction from the ground, two upward forces, and the weight acts towards the earth. So here also you can see three parallel forces. in equilibrium. Now, what is the next example then? Shall we have a look? What is it? It is called a danda. Have you seen an a danda? A small bridge, right? So, you can see three parallel forces acting on this in this instance as well. Now, see, one reaction force is shown by this arrow, the other reaction force by the ground is shown by this arrow, two parallel forces, and the third force, the weight acts towards the earth. Here you can see three parallel forces acting on a danda or a small bridge. What is the next example shown here? Right, we'll have a look. What is it? Don't know whether you all have seen a picture like this. Now you can see mats are hung using some ropes. Now this is called in Sinhala Paduru Ana. Don't know whether you have seen this Paduru Ana. Now you can see they use some ropes to hang these mats. Here also you can see three parallel forces. Padurwana, and one means, now this is the tension or reaction force, tension of the ropes, and here also tension of the ropes, two reaction forces, and the weight acts towards it. You can see three parallel forces here, 1, 2, 3 parallel forces in equilibrium. Here also you can see a seesaw, and now these children, they are not moving, they seesaw. So here also you can see three parallel forces. The weight of this boy acts towards the earth, the weight of the girl acts towards the earth, and the reaction from this support, the support is shown here, the reaction force is acting here is shown by this arrow, the reaction force by the support. So how many forces are shown here? 1, 2, 3. Again you can see three parallel forces in equilibrium. But if these two children, if they are playing, if they are moving the seesaw, you cannot apply them. It is not in equilibrium. What is the next example? A solid body submitted to three forces whose lines of action are not parallel is in equilibrium if the three following conditions apply. Now we are going to discuss about equilibrium of a body under three forces that are not parallel. Now we have discussed about three parallel forces. Now we are going to discuss about the three forces that are not parallel, the way they in equilibrium. The lines of action are coplanar in the same plane. I am going to explain. The lines of action are convergent. They cross at the same point. The vector sum of these forces is equal to the zero vector. What is it? We are going to discuss. Now look at these pictures. In this picture you can see three inclined forces. The object is in equilibrium. They meet at the same point. They meet at the same point. What are the features? What are the features of this? They meet, the lines of action of the three forces must meet at the same point. The resultant of any two of the forces should be equal to the third force in magnitude and opposite in direction. Right? So it's given in your textbook. Here also you can see three inclined forces applied on the object. Right? T1, T2, the weight acts towards the earth. Three inclined forces. What is the next example? Now you can see again three inclined forces acting on this mirror. Now this is the tension of the thread shown here, and the weight acts towards the earth. So they meet at the same point. Here also you can see three inclined forces, and they meet at the same point. This tension and weight of the picture acts towards the earth. So when you join these three lines, they meet at the same point and they are in the same plane, coplanar forces. Right, that is the end of this lesson. These 2 units, I have discussed 2 units in your textbook, in your syllabus. Right, so I am going to wind it up, and please do subscribe to my channel to watch more videos. Thank you very much.